14. Determine whether the function is even, odd, or neither using the algebraic test. Okay, so you got to show this. Okay, what you've got to do is you've got to show that whether or not when you plug in a negative x value, okay, a negative placeholder there, okay, if you get this where everything changes sign, you will get an odd. This is an odd. And then if you do this, okay, and you get the same function, then that is even. Okay? Now that is not the same as having an odd power or an even power. Like when we say positive odd or negative odd when we're graphing it. Does it? It does, but it's a different type of problem. Okay? It's a different type of problem. So this isn't just saying, you know, this is an odd. Okay, just because it's a positive 3, okay? This is a positive 3, so it's a positive odd, but it might not be odd, okay? So what we got to do is we got to test this. We got to plug in, and you can probably already tell that it's not going to be an odd or even function, that this is a neither, but you got to kind of show it, okay? So this is what you got to show, okay? Just show it. Okay, oops, negative. Okay, and then what that does is it definitely produces a negative x to the third. So far, we're an odd, definitely not an even. He's actually off the table now. Okay, but now this guy, he's going to get squared, so he becomes positive, and then we get a negative 7x squared. Now that is the same, so now we got a combination. This is an odd and an even, so it's got to be neither. The sign change did happen on 12, but this guy is neither. Okay, and why? Because f of negative x does not equal negative f of x and does not equal f of x. Okay, and that's a beautiful mathematical description of why. So if it did say justify, this is the justification. Okay, now use the limits to describe the end behavior of this guy. Okay, well this is actually kind of nice because now we can think of this as a positive odd, okay, even though he's not odd in the algebraic tense. Okay, when we talk about end behavior, we know he's a positive odd, so his arrows are going to do that. Okay, and that is all we need to know to kind of draw this out here. We're going to go the limit as x approaches negative infinity of f of x, and then we're going to do the limit as x approaches positive infinity of f of x. Okay. And now we know that this arrow goes down to the left, so we'll put down, which is negative infinity. This guy goes up, so then we're going to go up. And all you had to do was just focus on this guy so that you knew how the arrows were behaving. That is 90% of the problem with polynomials. Just you want to know how the data flows, so you need to know if your polynomial is a good fit for you. Okay. Now find all the real zeros. So finding all the real zeros means this guy needs to be factored. Okay, so right now, if I did do, I'm going to need a little bit more space here. No, I can write this here. Okay, okay, 12x. Now first of all, I can take out an x, and what that does, it automatically drops the degree to a quadratic. So now once I take, they all have they got a GCF of an x, so I take that out. Now I got one parenthesis, or an x, and then this is going to be x squared minus 7x plus 12, and I bet you that's factorable. Okay. Now, by the way, I do know that one of my zeros is 0 already. Now, this guy, is he factorable? Yes. In fact, he's going to be x minus 3 and x minus 4. I said that backwards, but that is correct. So therefore, our zeros. Okay, so notice that it's kind of easy algebra. You just have to know what to do, okay? And hopefully we've done enough of these where I think that you guys can handle all of the math here. We just got to make sure we understand what it's asking us to do, okay? But these are the zeros right there at 0, 4, and 3. So where's this guy positive? Okay. Well, let's see. This is going to be kind of an easier thing to do. Okay. We want to know when it's positive. Well, if we know it's a positive odd, okay, we're going to use the Brock method here, where instead of like testing them, we can actually just go ahead and draw the flow on just the x-axis here, right? So this guy, all these guys are going to pass through. Okay, they're all going to pass through. So pass through, pass through, pass through. So where's this guy positive? Right here and right there. Okay, so he is positive at 0 to 3, and then from 4 to infinity. Okay, that's where he's positive. And you could test this too. You could actually go ahead and plug this into the calculator, throw in a 5, put a 5 in here, and just see that he's positive. It definitely looks like he'll be positive. Alright, now we're going to write a cubic function with these zeros. Now it looks like they did give us the pair here, and oh, they give us all 3 zeros. That's great. Okay, so this means that our function here that we'll just call f of x is going to be x minus radical 2, x plus radical 2, and then x plus 1. Okay, now we just took what we already know to be zeros, and then we're going to go to the factored form. Here we went from factored form to the zeros, so now we're just going backwards. And we are just going backwards. That's exactly what this is going to be. Let's go ahead and FOIL this guy out. And because these are conjugates, remember the middle terms are going to cancel out. So x squared, x radical 2 and x negative radical 2 are going to cancel out. So then I'm left with an x, negative square root of 2 times square root of 2 is just 2. Okay, and then this guy's just x plus 1. All right, now one more step. Just FOIL the guy. So now we get x squared times x is x to the third. X squared times 1 is just x squared. Negative 2 times x is negative 2x, and then negative 2 times 1 is negative 2. That is our cubic polynomial. We're all set. Now notice, think about it this way. Now we could probably group here, right? If we grouped it, we'd be going backwards. Okay, if we grouped it, we'd get this guy, then this guy would give us this stuff. Okay, so it's all just kind of a back and forth. That's a big part of pre-calculus, obviously. Okay, given that this guy is 1, 0 of this guy, find the rest of them. Okay, so let's see here. He's not. Okay, so I started this off wrong. I'm tired. We know that this guy is one of your zeros, okay, but that doesn't help us find we need a real zero, okay? This is imaginary, and he's got his other twin, right? Okay, so there's 2 of them. Now, that means I've got to have one other real root, okay, because I do have a cubic. So there's 1, 2, and one of them is going to be the third. So what we got to do is we got to use the rational root theorem to figure out what that other guy is. Now, unfortunately, negative 50 does have a lot of factors. But remember, we're just going to start with 1 and move up, okay? Now, luckily, our Q here is 1 and our P is 50. So let's write all of our factors. Now P over Q is going to be the same as P because it's just 1, 2, 4, right? 4 goes in there. No, 4 does not. 5 does. Then not 6, 7, 8, 9, 10. Not 12, 13, 14, 15, nope, 25. And then 50. Okay, I guess there's not too many. All right, yeah, that's okay. Okay, so now we got all of those negative versions too. Okay, so we got the negative of those two. Now let's just start with 1, and then we're going to just go ahead and do synthetic division. Now, unfortunately, I do not have my the enter key in front of me, so I'm going to have to test these. I'm going to try to do it quick, and I might have to bleed into other parts of the paper here. So 1, 1, negative 6, negative 6. That's going to be what, 14. Okay, that's not it. Let's go negative 1. That's going to be 1. That's negative. That's going to be negative 8. And then positive 8. Then that's not going to work. Let's try 2. Okay, 2. And you can watch this at 2 speed. I don't care. Just fast forward. Whatever. You know what we're going to do. We're looking for the 0. So I'm just going to do this in real time so that you can appreciate me taking the time to do this. Negative 10, 10, 20. That's not going to be it. Negative 2. Okay, that's negative 9. It's going to be negative 18. No, positive 18. It's going to be 38. And that's not going to give us a positive 50. So now we go to 4. I got a good feeling about 4. 1, 4, negative 3, negative 12. That's going to be 8. Nope. Okay. Now negative, I don't think negative is going to produce it. Let's try. Let's see here. Negative, then he becomes negative 11, negative 44, and that's going to be negative 6. No, negative, come on, 44 minus 20. Give me 24. And then, nope, that's going to be too high. Let's go to 5. One, 5, negative 2, negative 10. It's going to be 10. And positive 50. There he is, 5. That's it. I only need one of them. So it means then that we have 5. Okay, our zeros. Let's write this professionally. Zeros is 5, 1 plus 3i, and 1 minus 3i. Those are zeros, 2 of which are imaginary or complex, and the other one is real. So that worked. Okay, so the linearization of this guy is going to look like this: x minus 5, okay, because it's positive 5 that worked up there. Then you got x minus 1 plus 3i, and then x minus 1 minus 3i. Okay. Now what I did is when I grabbed this, like this mistake here was that I tried to FOIL these guys out, and then I was going to divide this into that, but it was getting super messy, so it was just too much work. I knew something was wrong. Okay, but anyways, the hard work was just finding which one of those factors produced the last zero that I needed. Okay, last problem. Find the quotient and remainder when f is divided by g, and then is g a factor? Okay, so is g a factor is asking, do I get a remainder of 0? Okay, if I do, if it's a yes, then it is a factor because it means it goes in evenly. Okay, so I'm just looking for it to see if it's a 0. So I can use synthetic division in this case here, okay, but maybe this guy, nudge, nudge, wink, wink, he might not be x minus 2. He could actually be x squared plus 2 or something. Okay, so I'm going to do this the long division way because I got a feeling that on your test, nudge, nudge, wink, wink, if this guy's you're going to have to use long division. So let's do that. X minus 2, it's going to go into 2x to the third plus 8x squared. Now what you can do right now is you could actually pause it and just try long division on your own just to see if you get the result, okay, that you need. But we're going to need to produce x, turn it into x to the third power. We're going to need 2 of those x's, and we're going to need a 2 in front of them. Okay, that gives me 2x to the third minus 4x to the second power. And we're going to go ahead and subtract those guys. Okay, so those guys go to 0. This is 8 minus negative 4 is positive 12x. Now, what is it going to do for x to become positive 12x squared? Well, I would require a positive 12 and another x. Now I'm going to drop this negative 5x down, and then I'm going to go ahead and do this again. 12x is going to give me 12x squared, and then this times that is minus 24x, and I just feel like the numbers are getting a little too big. I don't think this is going to be a remainder of 0. Okay, negative 5 plus a positive 24, because we do have a double negative there, is going to be 19x. What's it going to take for x to become 19x? Just 19. Okay, so 19 times negative 2 is not going to be positive 5, where I'm not going to get a remainder of 0. Okay, so find the quotient and the remainder. Okay, then the last question is going to ask, is it a factor? So we just need to get that remainder. Okay, so we're almost there. We just have to drop that 5, and we're going to subtract 19x, and then 19 times negative 2 is going to be negative 38, which this ends up being 43. Okay, So our final answer is 2x plus 12x plus 19 plus 43. Yes, sir. Okay, so it is not a factor. All right, and that's it. That's how we write it. And you guys did pretty good on that last quiz on long division, so we're all set. All right, all done.